Hi ladies, it's Mr. O'Sullivan. Today we're going to be going over how to graph linear functions again. This is our third day of it, but remember you did learn this in middle school, so we want to make sure that we have all these skills mastered. Graphing in our course is very, very important because we need to make sure we can model situations graphically and algebraically. So today's learning target is I can graph a linear function by identifying the y-intercept and the slope. The reason why we're just identifying our y-intercept and our slope is because that's all you really need to graph a line. So before we begin, remember that these is your procedure to graph a linear function. In order to graph your linear function, your equation must be in slope-intercept form. In case you forget, slope-intercept form is just a fancy way of saying y equals mx plus b, where m is your slope, or your rate of change, and b is your y-intercept. You might have heard me also call it your start point or your initial value. So this is your start point. So this is the reason why I call it your start point and your initial value is because that's the first point you even look at when you graph your line. Okay. The steps that we do are we identify our slope and our y-intercept. And remember, slope is equal to rise over run. The reason why we want to say rise over run is because whenever we graph, we really are looking at a function's rise over run. So our first example, and then last but not least, you then graph it. So the first thing we want to do is we want to see if our function or our equation is in y equals mx plus b form. So I'm going to write down y equals mx plus b. So in y equals mx plus b form, my y is by itself. There's nothing on the side where my y is. Everything is on the other side of my equation. If I look, there's nothing with my y. Everything else is on the other side. I like this equation. So I'm going to go ahead and identify my slope and my y-intercept. Remember, your slope is the number attached to your x value. So in this case, the number attached to my x is a 3 over 2. So I remember in Zoom, a lot of you say, you know what, that fraction's really scary. I want to make it a decimal. No, that fraction's actually much nicer than a decimal ever will be. So please, please, please leave your numbers as fractions. So we're going to go to the side and write down m equals 3 over 2. So our slope for this question is 3 over 2, which means that our rise is 3 and our run is 2. Our slope is positive, so our line's going to look something like this, or at least we hope it does. And then last but not least, we have to identify our y-intercept. So our y-intercept is the number hanging out by itself. So I'm saying my y-intercept is a 3. But it's not a 3, it's a negative 3. So we need to make sure that we are realizing that we have to look at our signs. So I'm going to write down b equals negative 3. So the first thing I'm going to do is I'm going to plot that y-intercept of negative 3. And then I'm going to plot my slope. Well, my points that I get for my slope. So I said that my rise was 3 and my run is 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I'm going to keep on going until I run out of room. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I can't go anymore. So I'm going to erase those little dashes that I did to show my jumps. And it already looks much nicer and cleaner. So I can draw my line right now, but I want my line to be pretty nice. So I'm going to now, instead of go up 3, I'm going to go down 3. And I do this in regards to my y-intercept. So I'm going to go down 3 and to the left 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I'm going to get rid of those dashes. And look, I can now connect those points with a straight line. Not bad. And then last but not least, I write the equation that I just graphed next to my line, or on top of my line. It doesn't really matter. So I'm going to write down y equals 3 over 2x minus 3. And that's the equation you just graphed. Now let's go on to our next example. Before we do that, if you notice, I have a table of values. You don't need to do a tables of values. If you want, you can just do the slope-intercept method, which is what we just did. If you want to do the table of values approach, you would fill out this table of values by using Desmos. And if you have any questions, I can go over that in a small group or during an extra help session. So our next example, I need to ask myself, is it in y equals mx plus b form? If I look, I have a plus 2 with my y. So it's not in y equals mx plus b form. I want to get rid of that plus 2. I also have parentheses. So I really need to figure out how to get this into y equals mx plus b form. So what I'm going to do is I'm going to rewrite this equation. So y plus 2 equals 3 times x minus 1. And remember, whenever I have a number on the outside of my parentheses, I'm going to distribute. So I'm going to distribute that 3 to my x and my 3 to my negative 1. So I get y plus 2 equals 3 times x, which is 3x, and 3 times a negative 1, which is a minus 3. It's starting to look a little nicer. I want to get my y by itself, so I have to get rid of that plus 2. So I need to get this 2 over here. So the only way to get rid of a plus 2 in our class is to subtract 2. Subtract 2. My 2's cancel, so I get y equals 3x minus 5. That is the equation I'm graphing. So remember, y equals mx plus b. The number attached to my x is my slope, so in this case it's a 3. But whenever you have a whole number, I always put it over 1. That way I know I have to run a little. So I rise 3, and I run 1. Now the number hanging out by itself is my y-intercept. So in this case, it's a negative 5. So I have a positive slope and a negative y-intercept. So the first thing I'm going to do is I'm going to plot my y-intercept at 0, negative 5. And now I'm going to rise 3 and run 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. I'm going to erase those jumps that I made because it doesn't look nice. It looks sort of like a mess. It looks like a kindergartner did it. And now I will have a lot of points that I can use. But what I want to do is I want to make sure I get a really nice whole picture of my graph. So now instead of going up 3, I'm going to go down 3. 1, 2, 3, 1. And I ran out of room already, so I can only really plot one more point. I'm going to connect those points with a line. Oh, this is not going to look like a nice line. Let me redo that one. Much better. And then last but not least, I write my equation. I can write y equals 3x minus 5. Or you can write the equation you started with, which is a y plus 2 equals 3 times x minus 1. Make sure you name your graphs. You have a name, your graphs need a name. Now let's go on to our next set of problems. So in this example, I have 2y minus 3x equals 10. I have to ask myself, is it in y equals mx plus b form? Well, it's not. My y's and x's are together. So I need to solve for y. So to get my y by itself, I have a 2 attached to it, so I can't do anything with my 2y, but I can get rid of my minus 3x. So to get rid of my minus 3x, or cancel it out, I'm going to add 3x to both sides of my equation. My 3x's cancel, so on the left-hand side, I'm left with 2y equals 3x plus 10. The reason why it's 3x plus 10 and not 13x is because 10 and 3x are not like terms, so I cannot combine them. Now I want to get rid of the 2 that's attached to my y. This is multiplication. There is no addition, there is no subtraction, there is no division. It's multiplication. When you don't see an operator, it's automatically multiplication. The only way to get rid of that multiply by 2 is to divide every single term in your equation by 2. So my 2's cancel, so I get y equals 3 over 2 x plus 5. That's the equation I want to graph. So in Zoom on Wednesday, I forgot who said it, but I think a few of you said this. The fractions scare you. When you're graphing, fractions should not be scary. Fractions should be our friends. Decimals are scary. I don't want to count 1.75 up and 2.3 to the right. I want to count nice numbers. So let's identify our slope and our y-intercept. Our slope is the number attached to our x. So in this case, our slope is a 3 over 2. And I always write down what my rise is. So my rise is a 3. And my run is a 2. And it's positive, so my graph is going to look like this. Now, my y-intercept is the number hanging out by itself. So in this case, it's a plus 5. So I'm going to go to my 5, plot a point, And I'm going to go up 3, right 2. 1, 2, 3, 1, 2. And I can't go up anymore. So now I'm going to plot some points to the left. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Now I'm going to get rid of all these dashes I did. Or tick marks, whatever you want to call them. And look, I got a bunch of points plotted. What I'm going to do is I'm going to connect those with a straight line. And I can write 2y minus 3x equals 10, or I can write y equals 3 over 2x plus 5. I'm going to just write my original equation because that's what I like to do. And that's your final answer. You can do the x-intercept and y-intercept approach, but your x-intercept is not a nice number because if you look, your x-intercept is going to be a decimal. So you're going to get a decimal approximation, which will be a little annoying. Okay, on to our final example. I have f of x equals negative 2/3 x plus 6. Remember, f of x is just a fancy way of saying y equals. So I'm really graphing y equals negative 2 over 3x plus 6. Remember, your slope is the number attached to your x value. So in this case, I have a negative 2, 3 as my slope. So my slope is equal to negative 2 over 3. And my y-intercept is the number hanging out by itself. So in this case, it's a positive 6. So I'm going to be rising negative 2, so I'm going to go down 2. And then my run is 3 to the right. So I'm going to plot a point at 0, 6. I'm going to go down 2 and to the right 3. So 1, 2, 1, 2. Yeah, down 2, right 3. So 1, 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 1, 2, 3, and I ran out of points to plot. So now what I'm going to do is I'm going to go up 2, left 3 for my y-intercept. So up 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, and plot my point there. Now what I'm going to do is I'm going to connect those points with a nice straight line. And that's your equation. So I can now write y equals negative 2/3 x plus 6, or f of x equals negative 2/3 x plus 6. And that's your final answer. So ladies, please, please, please make sure that you are practicing graphing lines. The graphing will not go away this whole year. It's not going to go away in geometry. Well, it will go away for a majority of geometry, but it's definitely going to pop up in Algebra 2 Trig and Pre-Calc and even Business Math. So if you have any questions, please email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.